Good afternoon, everybody. Thank you very much for coming along, giving up your lunchtime. I hope there's going to be something interesting for everybody. There's quite a lot of material here. I think there are some really helpful parallels between the UK and New Zealand, but they're not identical, right? And I recognise that. So if you think it's interesting but off target, that's okay. But I just hope there are things in here which fire some thoughts for you. So, beyond the walled garden, this is the feeling that we've had 50, 80, 100 years in a very comfortable place, generally speaking, for the power sector. Very well understood. So well understood, as I'll come to later, that I think many of the givens of the power sectors around the world are just not even understood to be givens because they're just taken for granted, and many of them are changing. But I'd like to pick up on that later. So here we are, the walled garden, very comfortable, but there is a gate. Okay, there's an outside world, and certainly what we're seeing in the UK, there's a need to now start stepping out into something that's quite different. I've got four topics here which will form the core of what I'd like to cover. I've said outside the walled garden, expectations are changing. Outside, if it can't be simple, then we have to simplify it. There's a lot of new technology, and new technology can be tricky. And finally, this is an area where there are tipping points. Right? Tipping points are uncomfortable for policymakers. They're certainly uncomfortable for industry. And they're very uncomfortable if you're servicing the customers who are tipping. When we get to these four topics in a few moments, I'm going to try and summarise what I think the challenges are and offer you what I think might be the directions for solutions. Okay, so you can see whether you think I've got the right idea or not. But before we dive into that, how are things inside the garden at the moment? Okay, now I think what we can see widely is that after 80 or 100 years, change really is happening to different extents and in different ways around the world in power systems. And there are multiple drivers for the change, for these changes. In many cases, certainly for UK, as John said, sustainability policies coming, in our case, from Europe and down into Britain. But also, I'd say sustainability as a consumer-customer attitude. Is evidently changing things. Renewables, distributed systems, storage, new types of customer loads, whether that's electric vehicle charging or for the UK, possibly a big uptake in heat pumps. It's very potentially disruptive for us. And then we've got automation, energy automation at a home level, business level, and new players bringing many of those services in. But this isn't uniform, there isn't a blueprint, I can't offer you kind of the answer. And it's not just technical, it's really bound up with commercial frameworks and regulatory frameworks. And finally, I think the biggest change, the most disruptive change, is we're seeing customers becoming less passive, more active in energy. And as I've said here, I think we're going to start seeing customers becoming part of the system rather than connecting to it. I think the mindset for all of us is we just plug in, we plug in, we just connect to it, it's there. But the way things are going, with enough of us doing it and enough automation, we are becoming part of the system and our behaviour influences the system. And it's fundamentally different, where we're going. So customers becoming part of the system. And the transformative changes, summarised, I think, a shift away from centralised systems. We had 80 years of progressively centralising things, big power plants, big control centres, and everything becoming more central. I think that's unlikely to continue. It's probably got a role for a long time yet. But what we're going to see, and it's certainly evident in the UK now, is a need to start integrating across the delivery chain. Generators, transmission, distribution, customers. We've certainly moved in the UK to a position where those are in quite clear silos. They don't really need to talk to each other. The rules are set out, everybody does their own bit of the business, and there's very little joined up activity, if we're honest. And then the edge technologies, things which are at the edge of the system or beyond the meter. This is driving the change. So variable power sources, solar, particularly coming along, rooftop PV, substantial new demands, big changes for the local networks. And then with those changes, and here's another kind of paradigm change, I think, generation following demand. Has always been the way power grids have worked around the world. Generation follows demand. That's having to shift towards demand follows generation. I don't know if you thought about that. So at the moment, the way power grids work is we just go and plug in, because we're not part of the system, or we just plug in, we take what we want, and somebody somewhere else works out how to get that power to you, because there's no storage in the system to speak of. So when you plug in or turn a light switch on, that has to have been generated just for you. Has to have been, because there's no storage in the system. All right, so the way the whole system works at the moment is about anticipating your needs, looking at the weather, knowing what happens certain days of the week or what's on the TV, right, and ordering, scheduling, either by instruction or by a market, enough generation to match the load. But if you start to think about generation being something that you can't pull a lever and control because it's governed by the sunshine or the wind, for example, then you have to start thinking of generation as something you capture when it's available. You start looking at the world where generation is something you harvest. All right, so you start to need that lever, but it's got to be a different one. It's one that varies demand. It brings demand into the times where the generation is available. Otherwise, we end up constraining low marginal cost generation. Okay. Many of the old givens are changing. A lot of the deterministic rules, right, that govern things going on in control rooms and design engineers and so on, those kind of rules are starting to become invalid. We'll come on to that. But we need much stronger data analytics, completely new modelling tools. And it's not just the maths. It'll need social sciences, for example, to understand the way things are going, I believe. And very disruptive behaviour that's now beginning to surface in UK is community energy. Right? And there was a feeling that, well, that sounds all a bit specialist, it's the odd village that's got determination to go off the grid or something. It's not. It's really, really changing things. This is the consumer behaviour shift. Right? We'll come on to that. And of course, it's not, when you say communities, a community can be a village or a town. It might be more virtual. It might be all the members of a gym. Or it might be all the owners of a particular make of electric vehicle who sign up to being aggregated in some way, or their behaviours that way. And what we're really seeing in the UK is the behaviour of the big supermarkets. Right, who've got a huge portfolio of refrigeration plant, right? And when they start to coordinate that activity and that behaviour, suddenly you're doing things which actually begin to move the whole power system. Okay. And the last one on this list, new commercial parties. Now that's quite threatening when you've got very long established incumbents, but the takeoff in things such as Nest thermostats, Google's interest in energy and commercial systems, new players coming along, aggregators of demand, aggregators of generation. These are entirely new players and have a lot of influence. Okay, let's move on a little more quickly through the next slide. Here's just a picture of what's going on with solar PV in the UK. If you've not seen it, we're now up to 8.5 gigawatts of capacity. That'd be more than enough to supply New Zealand, I think, wouldn't it? If the sun was shining. But this has taken off with incentives and feed-in tariffs, but that top purple line is without the renewables obligation incentives. Right? So things are beginning to change, but I think the picture at the bottom is quite interesting. This is the largest solar roof on the Land Rover plant in the Midlands, at Wolverhampton, 6 megawatt. A 6 megawatt roof, big enough for a town, This is how stuff really is changing. On electric vehicles, these are just a few snapshots of the international picture. In the UK, bottom left, 3,000 vehicles a month are being sold. There are 45,000 now on the road. And just in the last year, I'd say 45,000 in the UK market is enough to keep seeing them. Whereas a few years ago, you didn't really. You'd have to look very hard. Now it's at the stage where if I go into London, I'm sure to see an electric vehicle charging and so on. So things are really changing. And you can study that graph about what different countries are doing. Norway is way out in front. Partly financial incentives, as I understand it, but also just helpful kind of government nudges like being allowed to drive in the bus lanes or getting free parking or those kind of things are just the tipping point. And in London, freedom from the congestion charge that everybody else pays going into central London. Things like that. But when we talk electric vehicles, the discussion seems to pop up in the media. Oh yeah, but what's the range is the first question. How far will the battery take me? So you get headlines like these, the range anxiety, what's going on in different parts of the world, and so on and so on. And will this stop, really, the tipping point that seems to be emerging in EV take-up? Let me just take you to a nice picture that I found. This is 1923 Morris Cowley. So it's a Morris because it's William Morris, who I think is probably the driver. Cowley is a suburb of Oxford, if you don't know, just up the road from where I live, and that's where these cars were made. So it became the Morris Cowley bull-nose two-seater. And it had a range of about 120 or 130 miles. It's an interesting number, isn't it? That sounds a bit like electric vehicles today. But just look carefully at the picture. What's that? Okay. That's the can of fuel because the driver had range anxiety. Right. There's nothing new. This did not stop these vehicles, and you can almost hear it, can't you? The blacksmiths and the grooms and the others of the day saying, "Oh, you don't want to take one of those. You're going to get marooned somewhere. There's not enough filling stations." It would have been just the same as we're hearing today. Okay, so what flowers might we say are blooming in GB's garden? I'll zoom through these. We've had some very, very helpful, large-scale smart grid kind of projects. They've been funded by regulatory incentives to get them off the ground, and that's enabled big projects at scale. And there's masses of learning. And because customers have contributed or paid in large part, all the learning is available. That was the quid pro quo. So there's masses of information. The GB Smart Grid Forum has continued to roll forward, and I list there the various work streams and the transform model that some of you are aware of. There's been a work stream on regulatory barriers, which came up with a frighteningly large number of action points. And then there's the DS 2030 study, which I'm talking about tomorrow to the Smart Grid group here. There's an interesting shift reflected even in Ofgem's recent restructuring as a shift towards whole system thinking. Right? And that's beginning to move away from the silos I mentioned of generation, transmission, distribution, but it's also beginning to recognise that somewhere not too far away we're going to need to think about electricity combined with gas, multi-vector, combined with heat. Right? It's a huge, huge challenge, but that's the way it's moving. So when you start to look around in the UK, we have now something called the Energy Systems Catapult, which is, I think, a bit like your Callaghan Innovation Organisation, promote technology through the value of death to commercial application. That's energy systems, not electricity systems or power systems. Okay, and National Grid's system operability framework has very helpfully started to look at cross-system issues. The other thing that Ofgem's doing, if you follow regulatory themes, is they've captured the word flexibility. And that flexibility is a watchword for them for a whole range of initiatives. There's some very well-written, in my view, well-written consultation documents coming from Ofgem. But this is looking at flexibility on the demand side, particularly about demand-side management and so on. It's also about storage and introducing storage as a flexibility feature and shifting what we would call DNOs, distribution network operators, lines companies, into being DSOs, distribution system operators. I'd like to come back to that later. So there are changes. And finally, and this could be the topic of an hour on its own, the Future Power System Architecture Project. Its final report goes to the government today, UK time. It's taken 6 months intensive work, and this has been funded by the government department to say, well, when you look out to 2030, what is the best view of the changes of functionality to the power system? Right. And what it reveals is a substantial number of new functions needed, substantial, 30 odd new functions. And when you start to look at those, and you start to say, well, okay, but who is going to coordinate those functional changes? Who's going to bring those functions forward, especially if they are across the system? Have we got the governance processes for that? And it immediately reveals that what's been reasonable governance for the last 20 years, no way is it going to deliver this kind of new functionality in the future. But this will be, I hope, published before too long. Okay, let's move on. So let's think about going through that door into the world outside the garden. Other industries have been this way, haven't they? So here's one example. Right? The mobile phone sector, from 1985 right through to now, continual improvement, starting with this will never catch on, through to something I can't be without. It's kind of development that's going on. And I think the message I take from this is don't underestimate where things can go. The phone on the left, you'll, I'm sure, know, is the Motorola 8000X. £11,000, $20,000 in today's money, right? And a 30-minute battery life. I'd like to try and just run a very short video clip, which you might like to see, of how this all went. So here we go.
Weight and compact, so that you can easily carry it with you when traveling. The Opal has a 30-number memory, a 24-digit capacity. It allows for pre-call dialing so that numbers can be entered before call charges begin. It has an electronic volume control, allowing independent adjustment of both the speaker, handset, and incoming ring levels. A noise-cancelling microphone to reduce background noise, and a voice-operated transmit to extend battery life. But the great advantage of the Opal, of course, is that it is not only mobile, but portable. The Opal comes with a free spare battery pack. Each battery has a capacity of 10 3-minute calls, so that you can be on the move with 2 fully charged batteries and make calls for a total of 1 hour before recharging. There are 2 ways of recharging the batteries. First of all...
And so it goes on. Isn't it telling, okay? That for some of us seems very recent. I think what I'd say is the phrase that was used at the time is, this is a brick. It'll never catch on, this thing. It's described as the brick. And that caught people's imagination. Oh, you've got one of those bricks, you know? But I'll come back to this in the future. Do remember the bricks, because what we seem to suffer in our kind of human thinking about things is that we underestimate the long term. You know, we seem to get taken by surprise by this evolution, but it happens. It happens very, very frequently across different technology sectors. That the technology improves, the performance improves, and the costs fall. There's a trade-off, though, with that you get greater complexity. All right? So as you go forward in this path, the complexity grows. So let's come back to that. But just remember that when people are saying that these electric vehicles won't catch on, or the solar panels aren't efficient enough, or these batteries don't have enough cycle time, they're all bricks. All right? They're all at the brick stage. In 20 years' time, we'll be playing little video clips like this about the things which we regard as hot technology at the moment. It's really worth bearing in mind. Okay, so let's come back to to these 4 topics and take some challenges and potential solutions in them. So the first one was expectations are changing outside. The as-a-service economy has really exploded. Okay, this is abundant choice for customers, classically from companies like Uber or Airbnb. This is happening across sectors. It starkly reveals customer choice, all right, and service and prices. And these organisations have masses of users or partners, but not employees. So I've heard it said that Uber is the biggest taxi company in the world, but doesn't own any vehicles. And Airbnb is the biggest hotel company in the world that doesn't own any beds. Now, who might be the biggest electric storage company in the world that doesn't own any batteries? Okay. This could be where we're heading. Okay. Associated with this, and one of the reasons these service models seem to work, is that individuals seem to increasingly favour peer-to-peer, local thinking, something with their neighbours or their virtual neighbours, somebody they identify with. And of course, apps and mobile devices are perfect for that kind of connection. Now, in the UK, the classic one I see is called Gumtree. There's also Streetbank and FreeCycle. Come to these in a moment. But these are organisations which kind of connect you with your neighbour. Right. We've also got a government agenda in the UK, very supportive of devolvement, things away from Whitehall, localism, right, involvement of local communities, closer integration with the voluntary sector and so on. Right? So this is all moving towards that community and community energy theme. And then there's a massive agenda, again, a talk on its own, smart cities, the Internet of Things, and there's Cisco's figure, 50 billion devices will be connected, everything from intelligent streetlights to the home energy automation to 101 other things, which are all moving quite fast at the moment. And how should this sector that we know start to respond to this shift in expectations, shift in understanding? Now, I was at a lecture at Imperial College in London a few months ago, and smart grid stuff. And at the end of it, I just started chatting to the person next to me, who turned out to be a young lawyer. And we got onto some of this kind of power system stuff, and I talked about we really need to sort out how we're going to charge all these electric vehicles so they don't blow the fuses in the grid and that kind of thing. And this person simply said, "Oh, that's no problem. There'll be an app for that." There'll be an app for that. There's just an expectation, okay? These things can be fixed. And they're somehow fixed somewhere else, and I'll download it from the App Store. Right? That's the expectation, right? And we need to somehow get ahead of that, because otherwise we just have absolute frustration. What do you mean you haven't got an app for charging my car, or whatever the issue is? So possible solutions in this area. Customers need to feel every new service is simple, personalised, quick, anytime, anywhere. They're the kind of things that we should be looking at. So if we're thinking aggregation or smart charging or 101 other things in the power sector, or even making new connections or interfacing with an energy community, these are the things that are going to challenge us, I think. Consumers expect to interact through many channels, preferably mobile. Okay. People really expect to have their data leveraged and personalised, so that when you connect into something, it kind of knows you. Okay. And when you look at the way these new entrants are operating, of course, you don't often get an instruction manual, and it's pretty hard to find a helpline. Right? But they operate such that when anybody has a difficulty, that person has such good service that they tell their friends. "Oh, I had that problem and it was fixed straight away." Right? And then no damage is done if you can get customers acting as your ambassadors. It doesn't require a huge call centre. It's some other model that's being used successfully in other sectors. And then, this wouldn't be surprising, thinking of a new service, you'd say, well, what service does this give to people? What need does it satisfy? What emotion does it evoke? Hang on, John Scott, emotion, a group of power systems people in the audience here, emotion. When you look at the way these new services are going, many of them are tapping into an emotional response. Okay. So I mentioned TradeMe and eBay and Gumtree. I think we have eBay. It's highly commercial. It's an auction process. I think like TradeMe for yourselves. All right, it's where you could run a business. You're going to maximise your sale price or whatever. All right, but if you go to Gumtree in the UK, Gumtree is more like a small ad on the notice board in the local dairy or somewhere. Okay. This is about finding somebody who's pleased to take your old bike that you've been trying to get rid of or whatever, right? And they give you $5, and they go away delighted because they found an extra bike that they needed. You've got a $5, and there's a feeling of that was a good deal. Right? So when you look at the way these services are moving, there's something about emotion, there's something about community, doing the right thing for community. And this was on the London Underground across the platform from me. So this is an advert for Gumtree, right? And the catchphrase says, opportunity starts on Gumtree. It doesn't say, come to Gumtree, we're the cheapest or the fastest or the most accessible. It says, come to us, opportunity starts here. And the actual poster says, grab life by the handlebars with a young child learning to ride a bike. You see where they're coming from? This is not driven by hard-edged economics. This is the best price at all. No mention there of price. Right. So we need to tune into this, I think. I don't know whether Poster Note is your equivalent to Gumtree. It's the best I could find. Any of you use it? Anybody use Poster Note? But one of the reasons that Gumtree is so successful in the UK is that it's localised. It's people in your town, your postcode, or whatever. Okay, so that was the first one. Number two was, if it can't be simple, then simplify it. How many remotes do you have next to your armchair? Does it look like this? Mine certainly does. It isn't a pretty sight. And the kind of consequence is this, the granny remote. Yeah. And I'd say it's the kind of solution you get when there isn't proper thinking, actually. All right? This shows frightening lack of coordination. This isn't helpful to customers, is it? All right? This is making customers make do somehow. So back to the armchair. So much consumer technology is clumsy, confusing, or inconsistent. And if you start to talk about energy, well, is it energy or electricity, or did we mean power? All right, and we're not very good at explaining that. People rapidly get in a muddle with us. And we're going to have home energy management, smart EV charging. In the UK, we've got national smart meter rollout going on, every customer by 2020. And they'll all have interfaces and displays, okay? And we'll need assistance from time to time. So what we're getting, I think, is that as well-designed technologies mature, they do become easier to use. Things become more automated, more intuitive, all right? But really, they're getting more complex internally, all right? And on that really good technology, that complexity is concealed from us as users, all right? So hence, the title for this little segment, if it can't be simple, then at least simplify it, because the public, the users, are not going to engage with complex technology. They will want it made seamless, intuitive, all right, self-correcting. But how do we ensure things become great technology? What kind of things can we offer? Well, just before we answer that, I just pose a question. I know there are some EV drivers here, but whenever I look into the world of electric vehicles, I see a myriad of charging posts, charging suppliers. is this the equivalent of Granny's remote? All right, that if you want to drive any distance and you're not quite sure where you're going to get a charger, are you going to have a boot full of adapters? Okay. Like the remote, if you do, it's a sign of pretty poor engineering by those providing services to customers. Look how well the mobile phone industry does it. All right, I fly into New Zealand, I turn my phone on, it connects without me doing anything. I can dial back to the UK just the same as in the UK, and what's completely concealed from me is the whole world of roaming houses and making sure that all the people in the supply chain back to the UK get paid. And I don't even know how many people know of roaming houses. Right? It's so well done, right? And it's been coordinated. It's a highly competitive commercial area, but all these companies come together to hammer out agreed open systems and protocols. Then they go and compete. All right. So I do just wonder here, as we go forward, and we've got something similar in the UK. First of all, is there going to be some kind of open systems and compatibility for the power charging? But as we go forward, and perhaps vehicles can deliver services back into the grid, either interrupting their charging or returning power, you're going to want to plug in and make sure the commercial framework is seamless as well, and not have to press any buttons or put funny codes in, or be utterly frustrated when it says, well, you're connected, but you can't pay, so we're not letting you charge. Right? Utter frustration is going to be here if we don't get this right. So I just leave it as one of the questions to yourselves. I know you're developing more charging stations, but as they appear, do you have confidence that there will be interoperable open systems? You can have confidence that you can plug in and charge and pay, or be paid. So what can we do about technology solutions? Good technology normally has these characteristics. It's always available, all right? You can count on it working. It should always be connected without any intervention, all right? Your phone is doing that all the time, just polling the local mast, just saying I'm here. Right? You don't have to sort of join up and press a button to say, connect me. It does it for you, right? Good technology doesn't require parts or consumables, okay? And if you have an upgrade, it's downloaded seamlessly. Now, I don't know if there are any Tesla car drivers here, but I'm told, a Tesla is an iPad on wheels, really. It's much more electronics than anything mechanical. I'm told that overnight the software is downloaded and upgraded if you've got a Tesla car, and when you get in it in the morning, there's a chance that you'll find it's got a new feature. Right? You didn't pay for that. That just came with the overnight upgrade. Right? Delight the customer. Right? Good technology tends to be personalised. It knows about you, and it retains those personalisations across an upgrade, please. And with good technology, the interfaces are standardised. Right? That doesn't mean that everything's identical. It means you've got no hesitation. When you plug it in, the little light will flash green and then it'll go steady. All right? In other words, I've connected, it works. Plug in a new printer, it sorts out the interfaces and it just works. What it's doing is actually rather clever. And it goes away and gets the right software for you if you haven't got the driver on your laptop. Right? This is where we've got to go. So simplify it for the user, even if it's not actually simple. Right, number 3. Was technology can be tricky. So I'm aiming this a bit at some of the engineers here. Rising functionality comes with rising complexity, even if it's concealed. And then when you put new technologies onto power networks, they have to integrate with the existing network. Right? This is one of the differences between the power industry and, say, the mobile phone industry. Right? And also, unlike, say, the railways, you can't shut the power industry down while you do some of these integrations or upgrades. We're involved with an always-on system. Okay? So there's that integration task. And then, and we're just starting to work on this in the UK, is that as you start adding these smart solutions, whether it's real-time ratings or the management of storage or demand-side management, after a while, the penetration reaches a level where these technologies start interacting with each other. How do you commission that kind of equipment where your real-time rating interacts with your voltage control device, a feeder away, or with the demand-side scheme that the supplier is operating, the retailer? right? And how you're going to get hunting between control systems and so on. Okay. The biggest challenge that's been found in the work that's going on at the moment in the UK is not the technology of those smart solutions. There's no end of good ideas, and the ones that have been demonstrated are usually very good. The real difficulty is the data and the comms networks for shifting that data around. And the real test is not when you put a first demonstration project in, because you can hook that up with a bit of point-to-point piecemeal communication. Just, it'll be a mobile phone SIM card or something. Just get the data back, and then we'll work on it. But as these things start to be rolled out, you've got to find ways, of course, of having an expandable system, something which can efficiently integrate more data and aggregate that data and pass it to the users that want it. And certainly in the UK, we have absolutely no standards, no policy, no framework. Big control centres, yes, you've got well-proven comms over the years for a big SCADA system, but these are distributed systems. This is local processing going on. Okay, so it's going to need a completely different thinking and across the sector, and it'll need to be funded. And the tricky bit, I think, from a regulatory point of view, is if you're trying to set a strategy in place, there is probably upfront cost. Investment ahead of need, we sometimes call it. Right, well, you position the framework for growth. Right. It certainly brings challenges for commissioning, for spares, for maintenance, and what is the life, what's the asset management for power electronic devices, for battery devices, for demand-side management controls. What life are we going to put on that? How are we going to maintain and validate those kind of devices? What diagnostics are needed? Just one pointer here is that as we look at these more complex systems, one problem is just explaining to the people you're talking about really what it is and how do all these systems fit together. The SGAM model, Smart Grid Architecture model, is starting to get established more widely in Europe and parts of the US from what I see, and it's valuable because it gives you a visualization of these complex systems. And my last point, which I'll come on to in a little more detail in a moment, is that experience says there will be unexpected outcomes. Okay? Even when you've had a successful demonstration, proof of concept, when you start to roll things out or you scale it up, there'll be unexpected outcomes, all right? And there's a real need to manage people's expectations, or there's either a lot of reputational damage or even career damage that can really be avoided if people understand. So some suggestions on this page, this area of complexity. The first thing I'd suggest is in complex systems, so multiple component systems, be very wary of plug-and-play procurement. I've seen this happen where a quite influential procurement department steps in and says, well, we see you've designed this, but we think we can get the batteries from this company somewhere in Korea, and we get the control system from here, and we'll get something else from somewhere else. Oh, by the way, those sensors, we got those in Iceland. All right, and because the spec said these will all work to IEC 61850, blah, 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 and all the engineers say, yeah, that's an agreed standard, and of course you plug them together, they don't work. All right, and the rework can be extensive. And that's something we can talk about, but I'd say relying simply on stated compliance with open standards is unwise. It's an understatement, by the way. That's a British understatement. Simulation and bench testing are very helpful for new technologies, right? But they're no substitute for actually proving them on a power system. This is seen time and time again. And it's really, I believe, because only when you get on the real power system do you get all the non-linearities. You get lack of phase balance, you get harmonic distortion, you get funny things happening to the earthing. And those things don't happen in laboratories, usually anyway. Consider certified testing in independent laboratories. There are various laboratories around the world which can test things, either power devices or data devices, and test them right up to and beyond their limits. But I would say have your expert representative present. Okay. Testing is complex. You've got to be careful that the testing you're getting is really, really what you wanted. And I'd also recommend providing additional monitoring when you put early developments in, whether it's fast monitoring on the power system or it's monitoring of the intelligent systems, so that in the early days you're getting a lot of available diagnostics, because it will go wrong. We're sure it'll go wrong. The first static var compensator was installed in the UK in Scotland on a distribution network. It worked to treat. The vendor company went away thinking they'd done a good job, until overnight it went to zero, it went to float. And at the float point it oscillated. Right? But these things happen, right? It's not a fault, it's to be expected in complex systems, right? And it's about managing them. So you have to encourage a no-blame culture. All right? These are learning opportunities. They're not, as a rule, the failure of bad project management or something like that. And I'd also say that when you start to apply new technologies on networks and across commercial systems, it has to be a whole company initiative. It's not just something that comes from an innovation team. The innovation team understand these risks, but then when you start to roll it out, the whole company sees it, including the executive. So what do we go on to as the last point was the tipping points. Just still with me for another 10 minutes or so. In view of all the transformational changes, right, incremental change, incrementalism is really unlikely to be the way forward. Okay? And because consumers are involved, we can expect tipping points of behaviour. Whether it's individual consumers or communities are going to have no patience, absolutely no patience with the power sector not being quite ready. Right. And change in our sector takes a long time. And there is some scope, I believe, for doing things a little quicker, but it's never quick. Change in our sector is never quick. Right? And one of the reasons is the always-on system out there, the health and safety issues, live assets out in the field, in the public space. There are lots of reasons why we have to do things in a very, very measured way. Right? There are many new players coming in as well. And many of these things we've been talking about, if you think about it, they cross the system. The data is coming from homes, from communities, from electric vehicles, but it needs to be used by the network company at the distribution level, the transmission company for the national picture, and the commercial organisations who are making all this thing work. Suddenly we're needing data sources, data analytics, which cross all the players, in which case, who owns them? Who maintains them? Who has the strategy for them? Because they'll be out of date on day 2, right, in a fast-changing world. Where is that going to come from? It needs to be answered. And then, touched on this earlier, as we go to a more distributed world, right, I don't think it's fully distributed for a long time, but a more distributed world, is there a new role? I believe there's a substantial new role for lines companies, for distribution network operators, and we would call them DSOs. In New York State, the REV program would call them DSPs, distributed system platforms. Okay, these are bodies which are bringing all that data, facilitating change. All right. A nice American phrase from the REV project is DSP is there to animate the market. And this is a market for flexibility, demand management, vehicle charging. Who animates that, who brings it alive, so those individual householders or communities can sell a service or buy the service they want. It needs to be animated in American language. And I'd say that the business changes which go with these things are probably the toughest changes of all, tougher than the new technology, actually. So what might be some solutions here? Certainly in the UK, we're looking to try and ramp up the DNO to DSO thinking. How about a trial zone? Don't wait till the whole thing's hammered out and perfect. It's usually much better to do it in a contained area and run it as a trial, and then there's much more flexibility. Perhaps incentivize that. Certainly thinking of the UK companies, there are all sorts of reasons why boards of companies be hesitant to do this, or their investors and owners will be kind of hesitant to do this. If there's risk, all right, risk needs to be in some way recognised, otherwise why would they do it? And this is a particularly powerful one. We're talking about something really very complex, aren't we? We've been talking about multiple parties, multiple issues, and there isn't a blueprint, there isn't a master plan. So the first thing I'd say is going back to having a central planner, a nationalised industry central planner would be a nightmare. Who could possibly plan out something so complex? Right? This is where we need the best of the markets, of competitive behaviours, of people having access on an open basis to data and so on. All right? But these things all stumble unless there is what I've called here a shared sense of direction. All right? So if you've got complex industry, complex multiple parties, my view is not to be asking government or the regulators to have the answers, but it's to provide the signals, the framework, the roadmap, call it whatever you like, which starts to build a sense of ownership and share a sense of direction across different policy areas. The technical governance of sectors needs to look at, and this is this Future Power System Architecture project, and there'll be more about that coming from the UK shortly, I hope. And I believe also there's a need to keep the momentum of change going. And then that's a challenge, I think, for organisations like your Smart Grid Forum. You know, once you bring people together, in my view, it takes 6 months before they settle down to do some work, and you get substitution of representation and so on. And once you're starting to get some momentum, it's really helpful if you can maintain it. And then there's the changing givens, all right? So I'd like to just, if you're still with me for a couple of slides more, look at some of these givens. Come to that in a moment. But before we move into that, I'd just say, how about the positioning of the sector? Right? This isn't company, this isn't regulatory frameworks. This is the sector. You know, should the power sector that we've invested in over 80 or 100 years, should it be the platform for future change? Or is it the kind of dinosaur organisation which we really ought to be running down and closing down as quickly as possible? All right. Now, my personal view, and we can discuss it later if you like, is that there ought to be enormous value in a hybrid future where there's more devolved and smart systems working with a kind of national industry backbone. There are technical and commercial reasons for that. Right? But that's going to be incredibly difficult if the traditional industry is seen as the dinosaur. Right? And if it's anything like the UK over here, the traditional companies have got a hill to climb. Okay, it's not today's perception of the power companies being the future platform for energy, or in the US in the last few weeks, the super energy highway. Maybe that's a better phrase. Should our network companies be the super energy highway? Okay, so a couple more examples. Some of the givens, all right? I'd suggest, and I won't go through all of these, but these are the kind of givens that are so much a given that nobody really quotes them anymore. You know, demand is something you can predict. Diversity reduces demand. Customers are passive. Plant ratings for assets are seasonal numbers, summer rating, winter rating. Three-phase faults are the most onerous for the engineers. Short circuits cause fault current. Control engineers are in the loop. And 20 minutes is a good time horizon in the control room. Now, all those kind of things are given. And so are these. If you have a low-frequency problem, you trip feeders. Well, hang on a moment. If there's a lot of distributed generation down that feeder, do you want to really trip that feeder? Inertia. Well, inertia is something that's put in the system models, and it's the same figure for the whole country. That is completely out of date now for the UK. Taps alter sending end volts. When you re-energize, you restore the load. All of these things are seriously up for challenge now. And so on down the list. The third from the bottom won't worry you. Europe is somewhere else. Okay, but for Britain, you know, we have 1 or 2 interconnectors, a couple of gigawatts here and there. But the way things are going, we could become very, very interdependent with what's going on in continental Europe. Cyber attack is a risk for other sectors. You're probably aware that to my knowledge, the first fully successful cyber attack on a power system took place just a few months ago in the Ukraine. Right, so a malicious attack on the power grid in the Ukraine shut down customers in large scale. Very, very professionally done, probably state-sponsored cyber attack. And it was just in Smart Grid News blog this week that in America, the data is that the power sector receives the most cyber attacks out of all industrial sectors in the US. So I'd suggest that all of these can be challenged. Really, they are not valid givens for the future for different ways. And I'd just like to demonstrate one of them to you, which is on demand is something that can be predicted. So here is the well-known predictable demand curve. This is the UK one, but it probably looks very similar to yourselves. So there's a summer load in blue. This is for a day, and the winter load. So overnight, load is dropping, races up in the morning. There's a daytime plateau, and in the winter, we get a darkness peak at 5 o'clock or something on a winter's evening, when you've got lighting on and you've got commerce and shops all lights and people at home cooking and heating and everything else, and you get the peak. I did manage to find this graph, which is 1935. All right, this is just after, in the UK, we actually coupled up the whole grid as one grid. And when you look at the total line, they are remarkably similar shapes, but if you look at the y-axis, there's a order of magnitude shift or more. But the other thing that you can draw out of this, it would appear that industry shut down for lunch. And they probably did. So why is this shape and predictability important? Predictability is important. Well, the system peak is something we look at. The system minimum is important to other people. The plateau is important, and the ramp rate. These are typically important characteristics. And it's predictable and relied on by all parties in the supply chain. So peak demands is often the limiting case for flows or voltages, really important for the network, and perhaps we call it triad management, but peak clipping. Minimum demands, really important for the network as well. That's when we tend to get high voltages, but it's also when you can schedule in maintenance and you can take equipment out for construction and commissioning work. So you need to know when the minimum is. The plateau may in fact determine peak flows, and it's a long duration. And the ramp rate is really important for making sure you've got a credible power system that can ramp up and follow that climb. So you've got, in our case, we call them load profile classes. So our customers are divided up by their type of load shape. And those load shapes also inform cyclic ratings of equipment. So all just completely designed into the thinking. But let me take you through just a quick example here. So here is 4 days, all right? And the dark line is the demand curve over 4 days that we've just been looking at, but for 4 days, right? And if you stir in some wind, then the red line could easily be what the traditional generation would be doing. So on days when there isn't much wind, the traditional generation follows the demand curve, and on days when there's a lot of wind, it departs. Right? So that's what you get. However, if you think that, well, the wind energy is probably zero marginal price, then the price in the market is going to be set by that red line generation, the conventional generation. So when it's peaking, the prices will be the highest. So this will lead you, with time of use pricing and automation, to trim the peaks of the red line and to fill in the troughs. All right? So the green curve here is what you'd get if you shifted the energy from the peaks to the troughs. But then if you see what effect that had on the demand curve, what was that dark line now becomes the blue line. And what I think is really important is, whereas the dark line was a predictable, recognizable pattern, I would argue that the blue line is like a random line to the human eye. All right? And we've just said the whole industry bases its models and its commercial operations on a predictable demand curve and shape. This is just one slide to say how it's done in GB. I don't know if yours is the same, but we have a 3-year rolling data bank. This National Grid looks after this. It's a continuous and automatic correction process that goes top down. So it knows about the big generation data. That's high quality. We call it tariff metering data. All right? And we know highly metered exit point information from the substations. All right? So it's top down data. That is stirred in with the weather, the time of the year, the day of the week, all right? And it's using the turning points. It works entirely around the peaks and troughs, the turning points of the load curve, because they are always there. So the software can find the turning point, can find the minimum, it can find the maximum, and then it works to do its corrections and its tuning. But of course, if you've lost the predictable shape, then this whole methodology, I wonder how many people understand it anymore, because I think it's just automatically running in the background. How are we going to manage this? Now, if this is the case, that we're trimming the peaks, filling the troughs, then you can actually say top-down forecasting is dead. And the alternative has to be bottom-up forecasting. All right? But that means gathering data from individual customers. Suddenly, we've moved from a few tens of large power stations and some high-quality meters to potentially millions of metering points, data sources. It's a massive, big data challenge. Right? An awesome task, as this says, and it'll need a strategy. I won't dwell on this, but entirely new analytics, there's masses of new data, predictive information will be needed. We don't have the forecasting tools. We simply don't have the tools. I don't think they've been developed yet. And it's a whole system challenge, and I think you can also read on into this that the semi-manual controls in our big control centres of today simply won't be able to handle this. This has got to be a much more automated, intelligent system. So, getting very near the end now, I'd summarise those big 4 areas by saying I think it's really important to try and get ahead of the curve. Right? For reasons we understand, the sector changes slowly, and we need to really mobilise, or we will be subject to what I've always felt in my career is the worst insult or criticism, which is too little too late. Right? And I think that's where we could be heading for if we don't mobilise. And the other high level is, I think we have to go to them. We have to go to customers. We have to work with customers and other stakeholders, because we need to know what they want better than they know themselves at the moment. And when customers are saying, oh, we only want one flat tariff, we just want to take as much as we want when we want, I don't really believe it. We're much more sophisticated with our mobile phone tariffs and so on. So it's just because we haven't got that level of understanding and education in place yet. And finally, and thank you for your patience, just one slide on what I'd offer you, what I think might be the tough issues for yourselves. First of all, that change really does seem to be happening. Quite when it'll hit you and in what way, that's another question, but change seems to be happening around the world, and it's the changes that have tipping points. Those 3,000 electric vehicles a month are piling up in the UK now. Okay, there are tipping points in behaviours. Secondly, and we talked about this on the way through, in a multi-party sector, if it's not going to be subject to a master plan and a blueprint, you really need a shared sense of direction, otherwise everybody waits for everybody else. Many of the challenges we've talked about span parties and cross traditional boundaries. And when you start to see those, you really have to say, who is accountable then for it, if it spans boundaries. Open systems, all right, accessibility to data, to recognise protocols is a huge enabler for innovation, but in my view, it's never brought forward by the players in the market. The players in the market have every incentive to capture the market with their own bespoke system. But if somebody, government or regulator, maybe other parties, says, before we go too far, we want a common framework for data, then they all come and join in, because none of them want their requirements omitted from the standard protocol. Right? And you can see this in all sorts of areas. Right? So if you want open systems, you want standardization of something like data, somebody has to draw it together. I've asked here whether there's new roles, new value for the lines companies, DSO as we'd be calling it in the UK. But the challenge I think I see here is the fact that 29 companies, and do the smaller ones have the critical mass to handle the things we've been talking about, the innovation risk, the modelling, the understanding of more complex data structures, cyber. Who do you turn to if you're a tiny company? You want cyber, and you can buy a lot of this stuff in. It is a service, but then how do you become an informed buyer so you know what you're buying? Yeah. And back to that video clip, please remember the brick, okay? We tend to overestimate the short term. How many people have got deadlines for the end of this coming week, which they're going to have to work late to finish? We overestimate what we can do in the short term, and then we hugely underestimate the longer term and where things could go in the future, kind of human factor. And I just say on the end that wait and see isn't really a strategy. Okay? And it's not a strategy when you've got tipping points. Okay. So, as the saying goes, expect the unexpected, but I've also said enjoy the ride. But thank you very much for your patience.